Welcome to part 1 of solving radical equations. This video is going to focus on the very basics on how to handle radical equations, meaning there is some sort of radical that you are trying to solve for, and how to handle extraneous solutions, which we'll get into in a little bit. So with that said, let's get started. What you see before you is an example of a radical equation. We have an equal sign, which makes it an equation. We have a variable that we're trying to solve for, but what makes it the radical equation is the fact that the variable is under a radical. And if we remember our basic algebra, our goal is to get this all by itself. Well, in a radical equation, it's very simple. If I want to get the x alone and I want to get rid of this radical, I have to take or raise both sides to whatever power cancels out that radical. And since this is a square root, I can just raise both sides to the second power. This cancels out our radical and we're left with just x. And then 4 squared becomes 16. Now the thing with radical equations is we should check our answers. That's always a good thing to do in any type of math class, but with radical equations we could get something called an extraneous solution, where we follow all of our math and we get an answer, but the answer doesn't actually work with the original equation, which is kind of weird. But you'll see when it happens. So let's go back to our original equation, which was 4 equals the square root of x. But let's, instead of putting x in there, we found out x to be 16. Well, what is the square root of 16? Square root of 16 is technically plus or minus 4, but since our square root that we were given is positive, we ignore the negative solution. And the answer is just 4, so we get something that looks like 4 equals 4. If that is a true statement, we must have found the answer. And since 4 has to equal itself through the identity property, it must be true. So let's try another one. Here is another radical equation that's a little more complicated, but not terrible. We have 9 equals the square root of x plus 2, and notice that the plus 2 is not under the radical, so it's a separate term. Well, just like before, we want to get x alone. And if that square root wasn't there, what would we do? Well, we would subtract the plus 2. So if I subtract 2 from both sides, cancels out over here, 9 minus 2 gives me 7. So I have 7 equaling the square root of x. And just like last time, now I got to get rid of this exponent. Or sorry, not the exponent, I got to get rid of this radical. And I have to use the exponent that cancels out this radical. Since it's a square root, we use the power of 2. And whatever we do to one side, we have to do to the other. So 7 squared is 49, the square root of x squared is x, and our answer becomes 49. Now, just like before, if we're good mathematicians, we're going to take our answer here, and we're going to plug it back in to our original equation, just to make sure that it works out properly, because if it doesn't, we have that extraneous solution. So, let's move this over. We have 9 equals the square root of 49 plus 2. Square root of 49 is plus or minus 7, but just like before, since this is a positive square root, then we want the positive version of the answer. So the square root of 49 is positive 7 plus 2, and we hope that equals 9, and what do you know? 9 equals 9. So this is a true solution. Very, very good. Alright, we'll try a couple more examples. Maybe we'll see an extraneous solution in this video. Maybe I'll make you wait till part 2. We'll see. At first glance, this example looks like it might be a little bit ugly, because underneath the radical we have a fraction. And we all know fractions are the devil. Not really, but they're not always students' favorite type of thing to work with. So But the fact that all of it is under the radical helps, because just like before, I want to get this x all by itself. So with all of this under there, I can do what I've done in the last couple examples and square both sides. That cancels out our radical, and we have 2 squared, which is 4, equaling x over 3. Now, how do we get this x all by itself, since it's a fraction? Well, a fraction means division, and I'm dividing it by 3, so I'm going to have to multiply by 3. That cancels out our denominator to leave us with just x, and 3 times 4 gives me 12. Plug it back into our original equation. 2 equals the square root of 12 divided by 3. 12 divided by 3 is 4, so we have 2 equaling the square root of 4. And, well, once again, the square root is positive, so we have the square root of 4 equaling 2. And what do you know, once again, it is a true statement. So there we go. It looked ugly to begin with, but as long as we follow our rule of getting the radical by itself, squaring or doing whatever power we have to get to undo the radical, it works out just fine. Alright, let's do one more, probably one of the uglier ones we could possibly see. Alright, so here's the most complicated one that I could have thrown at you thus far. We have 1 equaling 6 plus the square root of negative 3 minus 7x. Well, our goal right now is to get the radical all by itself. Once we have the radical alone, then we can square both sides and try to get x alone. So to do that, we have a positive 6, so let's subtract 6 from both sides. And we have negative 5 equals the square root of negative 3 minus 7x. And right now, if you're on your A game, you're going to realize that this has no solution. How? Remember, a square root is going to give you either a positive or negative answer. But it can't give you strictly a negative answer. So the fact that we're having a square root equaling a negative answer, that's not going to work out. So right now I could say no solution. But this can also give us an extraneous solution, which is the same thing as no solution, but let's see how this works out in the end. So I want to get rid of this radical, so I'm going to square both sides. So I get 25 over here equals negative 3 minus 7x. Now, goal is to get x all by itself, so I have to add 3 to both sides. That's going to give me 28 equals negative 7x. And then to get x alone, I have to divide by negative 7. And I end up with negative 4 equaling x. So you might be thinking, hey, you said there was no solution, but we clearly got an answer. Well, we did. But remember, we're good mathematicians, we check our work. So I'm going to take that negative 4 and plug it into the original equation and see if it works out. So we have 1 equals 6 plus the square root of negative 3 minus 7 times negative 4. Okay, so let's see what we get. We get 1 equaling 6 plus the square root. 7 times negative 4 is negative 28. Since it's a negative 28 and we are subtracting it, it'll be a plus 28, so we have a negative 3 plus 28. When I combine these, I get 25. So I have 1 equals 6 plus the square root of 25. And since our square root is positive, we want the positive version. So, unfortunately, we get 1 equals 6 plus 5, which is not true, because we do not want 11. We want 1. And there we have it. We have an extraneous solution. X cannot be negative 4 because it does not work out to give us what we need. Hope you found this video helpful, and good luck with your intro to solving radical equations.